All right, here's example 2. Welcome back. Not much has changed with me. However, we have a much more elaborate function, so I'm also not going to lie to you. The only way to find what this graph looks like is one of two ways. One would be to put it in your calculator and graph it. That's a little bit cheating, but it would work. So I'm going to come over here and I'm going to start graphing what I know, and that is that the y-intercept is up here at 15. I'm losing a little bit of precision, but that's okay. The other way is to figure out the roots. That means I have to factor this. And that means I have to apply the rational roots theorem, which means any of the factors of 15 divided by the factors of 1 could be possible roots. And I'm not going to lie, I tried 1 and it didn't work, so I'm going to try -1 using synthetic division because this is pretty awesome stuff. So I write down all my coefficients, and this is how you can see how some of that other stuff you've learned before works. So that's a 1. -1 times -1 is -1. I add those up, I get -8. Multiplied by -1, I do get a positive 8. Add those up, I get 15 times -1 is -15. Can't really see my negative there. Gone, no remainder. That's exciting. That's a quadratic, which is basically x squared minus 8x plus 15. So if I were to factor this thing, it would be x minus 1. And then if I factor this, what multiplies to 15, that adds to -8 would be x minus 5 and x minus 3. And if I plot those, all those x-intercepts, they all appear to be, oh, actually, this is a -1, so that has to go in there as an opposite, so +1, thankfully. Otherwise, my graph wasn't going to work. So there's my x-intercept at -1. There's one at 3 and at 5. And then I know my graph is cubic and a positive lead coefficient, so it's got to come up, go down, come up like this. So what you notice is that I have two different areas. I have this area up here in which the cubic function is on top, and I also have this area right here in which the cubic function is on the bottom. So I have to write two separate integrals. I have to integrate the red area, which starts at -1 and it ends up at 3. And it's going to be the cubic function minus y equals 0. So I don't even need to write that y or minus 0 because it just doesn't matter. So x cubed minus 7x squared plus 7x plus 15. And then I have to add, because I'm doing a second one, and I'm going to do a blue one, and that is going to be from 3 to 5. That piece starts at 3 and ends at 5. And this time the cubic's on the bottom, so it's going to be 0 minus the cubic function. So again, I'm not going to write the 0 minus the cubic function like I did the last example. I'm just going to go ahead and subtract this function. So that is -x cubed plus 7x squared minus 7x minus 15. And all of these would have a dx. This dx is sort of shared by all of them. So there you go. Now I got to integrate each of them. And the integrals are going to be the same. They're just going to be opposites because of the flip-flop here on the cubic. So if I integrate x cubed, I should get x to the 4th over 4 minus 7x cubed over 3 plus 7x squared over 2 plus 15x, and that I have to integrate between -1 and 3, plus I have to do the same thing here. Oh, and I lied. No, I'm not lying. I'm adding both areas. Sorry. Plus, I'm going to have, again, this is going to be -x 4th over 4 plus 7/3 x squared minus 7/2 x squared plus 15x. You guys are pretty good with those types of integrals. No use substitution going on. And again, I have to integrate that from 3 to 5. It's the tricky part, and I'm going to have to scroll down, and it's going to be a lot of fraction business going on. And so I'm going to kind of show you how I deal with this. I got to plug 3 in, and then -1, and then I got to subtract those. So I'm going to put 3 into each of these, 3 to the 4th, and I'm going to put parentheses here, is 81 fourths. 3 in here is going to be 3 cubed is 27. and 27 times 7 is 189. And don't worry, if you don't do that in your head, that's okay. I did it earlier. I put 3 in here. 3 squared is 9, and 9 times 7 is 63. So I get 63 halves. And I put 3 in here. That's the nice one. That's just 45. Boom. Minus, and I'm going to put all of this in parentheses. If I put -1 in here, it becomes 1/4 because of taking a fourth power of a negative. This -1 is going to turn this -7, and there's already negative there, so that's going to become plus, and now I'm writing over top of myself, sorry, 7/3. If I put a negative in here, it becomes positive by the squaring, so I have plus 7/2 and minus 15. And I'm going to change colors just because I can. Plus, and now I have to plug 5 into all of these. And again, 5 to the 4th is 625, but that would be -625 over 4. And I'm going to kind of run out of room over here, and I apologize that. 5 squared is 25, and 25 times 7 is 875. So I am looking at my prior work when I do this, so that's why I am looking off to the right. Over 3, 25 squared is 25, and 25 times, wait a minute, this was cubed. How did you guys let me get away with that? That's why that number is so big. 25 times 7 is 175, but it's minus, so minus 175 over 2. And 5 times 15 is 75, so, and also that would be a minus. So see how easy it is to make these little mistakes. That should be a minus sign right there. Boom. So this becomes a minus 75 right there. Now I have to subtract all of these from plugging in 3. Now I've really done that over here. So I'm just going to watch the signs. So when I put a 3 in here, it'll be -81/4. And I put it in there, it'll be plus 189 over 3. And if I put it in there, it'll be minus 63 halves. And I put a 3 in there, it'll be minus 45. And I'm kind of at my boundary in my video screen here, but I did it perfectly. All right, there we go. We're going to scroll down a little bit and give myself some more room. I'm just going to, and this is like my own personal preference, I'm going to combine everything that has a fourth with everything else that has a fourth, everything with a third. I'm going to combine basically common denominators and try to make my life a little easier. So first thing I'm going to do is put 81 over 4. That guy's gone. Minus a fourth. That guy's gone. And I'm distributing this minus to each of these as I go. Minus 625/4. And over here I have minus, and all of these also have to be subtracted, so that minus and negative becomes plus 81/4. So for those of us who thought that having this cubic same function back here with the 3 but opposites was going to be nice, unfortunately it's going to change everything into the opposite, so it's not going to be that great. And I should have crossed these out and I didn't. All right, so now I'm going to do the same thing with thirds. So I'm just going to put in -189/3. And I know you guys love your calculators for this, but I don't have one. Minus this 7/3. Again, this is where you've got to be very neat. And so I apologize that I kind of wrote over it there. That's gone. Plus this is 875/3. And that's gone. And minus this becomes minus 189/3. So that's a minus, not a times. So again, I'm making sure I distribute each negative as I go. Now I'll switch to green. I'm going to do halves. So plus 63 halves. Gone. Here's a minus 7 halves. So again, be very careful with your subtractions. That guy's gone. That's a plus, but minus 175 halves. That guy's gone. And this is a minus and a negative, so it becomes plus 63 halves. And all my halves are gone, and I can start to feel a little bit better about the fact that all I have left are numbers. So I am going to, again, put a plus, and I'm kind of working down below myself here. 45. and that's gone. Minus a negative 15 becomes plus 15, gone. And this is a minus 75, gone. And minus a negative becomes plus 45. And I'm going to take a quick look and make sure I didn't make any. It's a matter of finishing things up, and I am going to kind of cheat this a little bit on you. If I add all these up, because they're all over 4 now, and I kind of did that off to the side, so I'm not going to kind of do it in my head. But when I add those all up, I get 80. That makes 80 plus 161, and if I subtract that, doesn't even matter, because when I divide it by 4, by my calculations, I came up with negative 116 for all the blue, gone. Now I switch to the purple, and if I add those all up, I got myself plus 490 over 3, gone. Switch to green, add all those halves up, and I ended up with negative 28. So again, you can go back and verify, but this is what I did on the side. I don't need you to watch me doing it. And finally, if I add these all up, and this one you could probably verify, I ended up with plus 30. Gone. So all of that work ends up being this combination of numbers. So again, if I take the time to add them up, I can add up all of the non-fraction numbers, and if I do that, I get negative 114 and plus 490 thirds. And if I convert that to a common denominator, which would be a 3, I'd have negative 342 over 3. That's what I would get with this one, plus 490 over 3, and I would end up with an answer of 148 over 3. That is the area of these two pieces added together, and that is it for me for now for that example. Again, you have one that you can try, and I went too far again. There it is. It's a you try, so pause the recording. Give this one a go. It's cubic as well, and if you need a help, I do believe that 1 does work, and so does negative 1. So you should try a little long division, but this is a little bit nicer because you can only do 2, 1, negative 2, negative 1 as your possible roots in terms of getting it. And actually, if you factor by grouping, which works as well on this one, I didn't even notice that, you could get it as well. So pause the video, try this one, and I'll show you the answer in a minute. Pause. Okay, video's on pause. Here is what your answer should have been. Again, I didn't notice the grouping, so I whipped through this, factored it, graphed it. There's your x-intercepts and your bounds. You got an upper and you got a top cubic, and then this is underneath, so that's why it's a minus over here. And then you integrate each, plug in your bounds. I went crazy canceling fractions, just like I did for the other example, and at the very end, should have been 37 over 12. This was a long example. I apologize and appreciate your patience. Enjoy.